So I am Sandipan and I will be conducting this session. So we have 4 talks lined up in this session, which encompasses topics from topics related to ethics and trust in natural language processing to differential geometry and graph neural networks. So our first speaker is Dr. Vivek Raghavan. Welcome, Dr. Raghavan. Dr. Raghavan is the Chief Product Manager and a biometric architect at the Unique Identification Authority of India. He has been responsible for the design, implementation, and scale out of the technology platform for Aadhaar, the world's largest identity program, mostly as a volunteer. He joined the Aadhaar project just when the first Aadhaar was issued and was there when the billionth Aadhaar was generated. So he has an MS and Ph.D. degree in electrical and computer engineering from Carnegie Mellon University and a BTech from IIT Delhi. In the past 3 years, Dr. Raghavan has been exploring the use of AI in many public and governance domains. He is driving many AI initiatives at Aadhaar in the areas of biometrics and document validation. So Dr. Raghavan has been responsible for guiding the development of ML models at GSTN and NPCI as Chief AI Evangelist at the EkStep Foundation. Dr. Raghavan has been advising the National Language Translation Mission to develop open datasets and open models for language AI technologies for Indian languages. So he also serves as the member of the AI Committee of the Supreme Court of India. He has been a long-term volunteer with ISPIRT Foundation, where he is a contributor to the DEPA. Over to you, Dr. Raghavan.
Thank you, Sandipan. And I will share my screen. I just want to make sure that, can everybody see my screen?
Yes, we can see your screen.
Okay, sorry. So first, thank you for inviting me to speak at this event. I have been spent probably the last 10 years of my life working on different kind of public good projects within India. And in the last 3 to 4 years, I have been involved in various kinds of AI projects, and part of it partly in the government and partly as a public good as outside the government. So therefore, I wanted to actually talk about 3 interesting attempts, and to tell the truth, they are still attempts to actually figure out interesting ways of creating data sets that can have societal benefit. And I want to just see that the various kinds of approaches that we are taking for this, and I hopefully as a result of talking here, maybe there may be certain collaborations that may come out of that. So I just want to at least give an idea of what kind of things are happening in this nature. So here I'm going to talk about actually 3 different kinds of works and 3 different examples. And really, I'm going to talk about specific examples of dataset creations that we are attempting to work in the public good space, in the societal space in India. The first one is actually is to leverage DEPA, and DEPA is actually I suppose India's answer to GDPR. It is something that is actually going through the parliament and other things. So therefore, it is leverage DEPA to create data sets to enable models in things like flow-based lending. So therefore, that's a first area, and how we are actually putting together, trying to create some kinds of a techno-legal framework to actually enable the creation of certain kinds of data sets for this thing. The second area which I want to talk about is actually related to the National Language Translation Mission, where basically we want to create an open data ecosystem for Indian languages. And at least I want to share how far we have come on this. And all of these are actually at the very early stage. And the third one is actually an effort which I'm involved in, which is basically creation of community-based data sets and benchmarks in the legal and justice domain. So, so therefore, I think hopefully this will be a coherent presentation with actually three very, very diverse things there. But I want to actually at least leave with the flavor of the kinds of things, of the kinds of data sets that we think are possible to kind of create in India, and specifically in the Indian context. Okay. So then first, I'm going to talk about moving to the first first area is basically I wanted to talk about the data empowerment and protection architecture. This is actually a techno-legal framework which for sharing of data between different entities. And at its core level, this DEPA framework, and this is actually something which is already been notified by the NITI Aayog in India. For those who are in India, well, notified by the NITI Aayog in India, and is also going to be part of the Privacy and Data Protection Bill that is currently in Parliament. But I think the core thing is some of the key things that we think that it is not only that obviously the right, the privacy of people's data is a fundamental right, but also the right of people to actually share their data for a relevant purpose to actually obtain certain services is also enshrined in this bill. So it is a kind of so therefore DEPA is actually a resident consent based framework where the consent flow is separated from the data flow, and the sharing of data is by definition purpose and time limited. So the data is, when it shares from one entity to another, the data is always shared in a manner that the purpose and the time of it is limited. In addition to that, the framework kind of ensures the accountability and authenticity of the data shared, because it is signed by the person who's the data provider, right? So this DEPA framework is already kind of live in at least in one domain, that is in the fintech domain. There is what is known as the account aggregator system, and that is actually uses this DEPA framework to basically allow people to share financial data for purposes of getting loans and those kinds of things. Now, the interesting thing is that we are actually so therefore DEPA is already there, and I think that but one of the extensions to DEPA that we are working is to actually extend data to create what is known as a confidential clean room, to actually allow very interesting places in the flow to actually do both model inferencing and model training in a kind of a secure manner. So therefore, it is, if you look at it at a very high level, what really a confidential clean room is actually, it's a policy-driven data sandbox. So there is a policy which guides what can exfiltrate from the sandbox, and it is a data sandbox which actually leverages some of the more recent, confidential computing kind of advances, so to say. So maybe before I move to the next slide, I want to say the key point is that there are three kinds of entities in DEPA. The first kind of are the people who are the financial information providers. These are the people who have certain financial information. The second entity in the place is the financial information users, who are people who can basically use this data to provide some service to the data. And then there is basically the data owner is the user, okay? And that is the person who is actually, that's the person who is the owner of the data, and the data flows from one entity to another purely on the basis on the consent, explicit consent, purpose and time limited consent of the owner of the data, which is the resident. Now moving to the, how does this actually, now we talked a little bit about DEPA, and I want to talk about how something like this could be, for example, used to, for example, provide so one of the things that in the account aggregator framework is to actually create an ecosystem. So therefore, when there is a person and the person wants to actually, for example, ask for a loan, then the loan information is actually so ask for a loan. What can happen is that the the resident can consent to share their information with not just one provider, but basically a marketplace of providers of loans. But when this case is, it is done in but this data is not shared with the consumer directly, but is actually shared to a clean room. And what this clean room actually would do, the clean room has actually got a data usage policy. And the data usage policy means that only those things that can be exfiltrated from, as for any use case, you have to have basically using a policy markup language. You have a concept of basically what is the data, what data can exfiltrate from the room. So then while the data is provided by the provider to the consumers, it is provided only within the context of the clean room. And what happens is that the person who wants to actually maybe potentially offer a loan to the consumer would actually move their models into the clean room, where it would basically, and then the model inferencing would take place in the clean room. And what would come out will be only that data which is consistent with the policy of the, which is consistent with the, which is consistent with the data usage policy. So it's basically, if you look at it, it's created, you've actually created a sandbox of data. And so therefore that allows you to share the data more freely with a number of people, because you know that the data is being accessed only within the sandbox. And the sandbox is such that and I won't get into the details of those things, but the intent is this sandbox are kind of, this is kind of you can basically remotely attest to the fact that the sandbox is actually, is in a legitimate state. So therefore that the remote attestability is one of the key points that you can actually do as part of this ecosystem. Going into a little bit more kind of a detail as to what does this sandbox look like. There are basically some of these kinds of, they start with the hardware root of trust, that all of these kind of sandbox are built on a hardware root of trust. And there is basically what this boundary is what is known as a confidential virtual machine, where there are a number of different containers which may exist. But the most important thing that these do is that there is basically a sidecar which is created, which traps everything that comes in and passes it through the policy engine before sending it to the application container. The application container itself is a black box, which may be doing various things, but it can't communicate with the outside world except through this except through this sidecar container, which is basically governed by the policy engine. And that's really the essential method by which you can technically guarantee. Obviously, there are legal guarantees that the data is used only for the purpose, but we want to extend this to be able to actually have technical guarantees that the data is only being used for the purpose for which it was intended, and that because that is coded into the policy. Now, moving to this same kind of flow actually is something that also can be used to actually train models in a manner by which train models in within a confidential clean room. In this case, of course, when in an inferencing flow, you're looking at one piece of data, but here you're actually in the clean room contains already anonymized data, right? This is the data even before coming in is anonymized, but it's only anonymized. So therefore, and then what happens is, instead of and this anonymized data is made accessible to an entity which wants to train a model. Okay, and the entity wants to train the model, but the training again takes place within this confidential clean room. And the intent is that when you do that, you actually create a model. And the intent of when you create that model, the question is that you then can run various differential privacy tests on the model created, so that you can prove that whatever has been created here is not exposing any of the data of the individuals which was used to train the model. Then the resultant differentially private model can actually be used. So why is this important? Because right now, if you look at it in the world, it's a kind of right now a new player can't come into any ecosystem, because they have no access to the data. And that is really the situation where, and so therefore you really have no, but what this allows is that multiple people can actually have access to the larger set of data and train more effective models, moving basically the entire ecosystem forward. And that's really the power here, that basically you can have access to much larger, much larger quantities of data to train models in a manner that is actually privacy preserving, and it is, and of course then it basically makes the ecosystem more vibrant and get more people into this. So all of these things, so these are all, so the work till here, I've been working with the ISPIRT Foundation, and I've been a volunteer with the ISPIRT Foundation for many years. So therefore, these are some, and then some of these account aggregator, this DEPA thing in the fintech space. It is something that we are working with a number of early kind of. I'm having trouble hearing you. So we are working with a number of what do you call that? Number of companies to actually pilot this and see how this works. And of course, the reason why this is important is this is a pattern which actually can be moved to many different domains. Even though this starting in the fintech domain, it is a pattern which can actually be useful in a number of domains. And that's really the intent to say that the techno-legal framework we have in India has opportunity to actually allow this kind of access to data, which I'm not aware is available anywhere else in the world. Now, so so we talked about basically, in the context of confidential clean rooms and DEPA, we talked about the finance. Now, the next one, we're actually moving to the National Language Translation Mission. And, I think this is a mission which was actually announced this year. And it's announced, it's not yet even actually been launched. So it's a little bit of a preview of what is happening in this. But the intent is to obviously, India being a multilingual society, to actually allow, break down the language barriers and provide content and services to citizens in their own language, both in the form of speech and text. That is the intent of the mission. But I think what's more interesting is actually how the goal is that how we want to achieve this mission. And I'm an advisor to the mission, so therefore it's the goal is to really create an ecosystem of players, including the government, the industry, academia, research groups, startups, and individuals, really, to actually create this ecosystem and actually work on looking at various methods to actually create large open source. And here we are about open source data sets by bringing in all contributions, both institutional and citizen ways, to basically create a shared repository that everybody can use for innovation. And then, of course, once you build this kind of base, and we'll talk a little bit about the architecture, the intent is to actually allow the ecosystem, not just while certainly the government and public entities will build certain kinds of reference products and services, but the intent is actually to leverage these data sets and these models and to actually build various kinds of applications. Therefore, that's the architecture of the thing itself. And I think that one of the key things, and what I'm going to talk, there's lots of things, layers here, but I think the core here is actually this data model and benchmarking repository, which I have in the middle layer over here, which is actually kind of which is being served by this unified language contribution API Ulka, which we'll talk about in more detail on collecting different kinds of data sets and models for Indian language kind of applications. And if you look at it, on top of that, we want to build, and we have already built, crowdsourcing apps, benchmarking tools, open APIs, catalogs for discovery of models and data sets, leaderboards, and these kinds of things. So therefore, this is actually the foundation layer. And on top of that, of course, our intent is to build various kinds of reference applications, but primarily also allow the marketplace to innovate and create and make sure that all the services that we provide are not just in English or a few Indian languages, but is available widely across different languages in there. And at the top level, of course, we have, we have the campaigns and innovation challenges and things like that. So maybe I'll just, this is, how are we for time? I think I will basically have a video here. It's about 6 or 7. I'll at least start the video. Maybe we'll stop it a little bit, 6 or 7 minutes long. And then I'll encourage people to go to the Ulka website, which is basically talks about this, what this effort is. So I'm going to play this video.
Hello everyone, welcome to Ulka. Ulka, which stands for Universal Language Contribution API, developed by MIT, is a standard API and open scalable data platform for datasets, models, and its benchmarking for the Indian languages. Ulka will help researchers develop language AI technologies including machine translation, automatic speech recognition, and optical character recognition in all 22 Indian languages. Ulka aims to become the premier repository for the Indian language resources. All the APIs used in Ulka are documented as open APIs using Swagger. There are 3 main components of Ulka, namely datasets, models, and its benchmarking. To train AI models, large amount of data are required. Ulka has a collection of such large datasets that have been collected over a period of time. Ulka supports summation of the following type of datasets: parallel corpus, which are basically parallel sentence in 2 different languages with the same meaning; ASR or TTS datasets, which contain audio to its respective text mapping; ASR unlabeled, which are audio file snippets without the transcripts; OCR datasets, which are images to its respective text mapping. Ulka will expand to other dataset types such as POS, NER, NLU, and NLG, etc. The dataset contains records belonging to various domains such as news, education, finance, healthcare, sports, and many more. These records are collected through various methods such as machine translated with post-editing, auto-alignment algorithm, crowdsourcing, etc. Ulka also contains a repository of language AI models in Indian languages. These models have typically been trained using the datasets we talked about earlier. A trained language AI model performs some specific tasks such as machine translation, which means automatic translation of text from one language to other language; automatic speech recognition, meaning automatic transcription of audio data in Indian languages; optical character recognition, meaning automatic detection of text in Indian languages from images. Already, 59 models in machine translation, ASR, and OCR have been submitted to Ulka. Over time, it is expected that researchers will submit better tuned models for the various language AI tasks. Let's demonstrate how some of these models work. Let's start with translation. Maybe we can search for English Telugu and select, say, Anuvad English Telugu V1 model. Let's try this model. So we have the output for the model. Now let's try out something in ASR. Let's try a Tamil ASR Vacancy model. Let me click here and do try me. Okay, let me try speaking a fairly lengthy sentence here. பிரதமரின் ஏழைகளுக்கான உணவு பாதுகாப்பு திட்டம் தீபாவளி வரை நீடிக்கப்பட்டு மாதந்தோறும் 80 கோடி மக்களுக்கு இலவச உணவு தானியங்கள் வழங்கப்பட உள்ளது. Cool. Let's convert. Check the output. Okay.
भारत की विभिन्न भाषाएं कम से कम 4000 साल पहले उत्पन्न हुई। भारत से निर्मित उनकी लिखने की अलग अलग विधियां जो ईसा मसीह से भी 500 वर्ष पुरानी है। भारत में हर 50 किलोमीटर के बाद भाषा बदलती देखी जा सकती है। Let's convert it. Converted text is now shown in the output window.
Let's try something from the OCR model. For OCR, let's consider an image text. We will
So,
share detailed information in further videos.
so I'm going to stop here. So, but in the end, I think that let's go back to, how do I get back to the, so the intent, one second, how do I, yeah, so therefore I think that you can go through the thing, and there is also the Ulka Live website, so you can actually go and see what is there. This is actually in a pre-release form, but it is available and at this link, and you can actually go and see live and try out the various benchmarks. There are a number of, so yeah, the important part which I actually removed there is extensive benchmarking. So therefore every what do you call that model can actually be benchmarked against all the published benchmarks that are available for that class of So I mean, just to go and show you at maybe just a quick view on how benchmarks looks like, and this is, I'm showing it live here. So if you see here, like for example, let me just put something in Hindi. So yeah, so therefore this is a WAT this thing. So therefore we have various different WAT benchmark for 2020 for English Hindi translation. And so basically, and the interesting thing is anybody can actually as long as you have an endpoint, you can actually self-publish your own results on this leaderboard. So therefore that's a so I'd encourage people to go, if you're interested in this thing at all, to go in there and look at these things as far as. So let's now move on to and then of course the other interesting thing which is there as part of the national mission, which I won't talk about, is actually there's a crowdsourcing app where people can actually help contribute to their own language by correcting or contributing either their voice or transcription capabilities or translation capabilities. So therefore, and all of this actually, the intent of this is to actually make this to involve school children, involve kind of other people and language enthusiasts, various people, to actually help collect larger data sets to be made available in Indian languages. So that's the Bhashadan crowdsourcing website is actually, that's the purpose of that. I think this the intent of this is to actually there is a roadmap for this, and I won't go into too much of the details, but the intent is to actually, we've already published the API, we've created the repository, the benchmarking system, and had various kinds of data collection tools. And the intent is to actually use this foundation to actually achieve kind of English equivalence in terms of language AI capabilities, NLP capabilities in all Indian languages. That's the intent of this mission, and would look forward to having people help and join us in this journey. Now I'll switch tracks to the next topic, which is actually kind of to create open source software and data sets, to create AI-powered solutions to advance access to justice. And this is completely a community-driven activity known as Open NIAI. And the intent is to actually, develop benchmarks that are relevant. So create data sets and create benchmarks, much in the style of, style of Squad or something like that, to actually create meaningful benchmarks in the Indian legal domain and allow researchers to come and to try their hands at these benchmarks and to see whether we can actually solve problems that we think are important in the Indian legal, Indian legal space. And of course, the goal is, if we make good enough benchmarks, and I'm not saying that we have so far, then we can actually push the ML community to work on NLP tasks that actually benefit the Indian legal system. There are a number of lawyers who are part of our team, and of course, there's a number of different tasks, and we have actually published a white paper of the various kinds of benchmarks we hope to create as part of this this entire effort. I think one of the early benchmarks that we are working on is basically trying to create structure out of court judgments that are there. So therefore, basically to identify the rhetorical rules that are there as part of any individual judgment, and to kind of classify the entire judgment into one of these, one or more of these categories, and actually try and that's one of the benchmarks that we are working on. This has obviously, while itself it's an intermediate output, it has a number of implications, including better summarization and better understanding of similarities between cases. There are many applications for this class of things. So we were one of the early areas to actually create this. Of course, the rhetorical rules can be used for summary creation, judgment prediction, charge identification, precedent recommendation, and a number of different things. That's one of the benchmarks that we've created. This benchmark is actually live, so you can actually go and look at this data set and try and look at understand and try to see contribute and see what there is a baseline result which is also there, and it is live, so you can actually go and submit something and see what you can do with it. Now, this is obviously one of the unique things about this was actually created by the data sets itself were created by law students and law experts, and they actually created and hand annotated and made some of these data sets. Of course, there's a bunch of tooling that is involved around that, which actually helps tooling which allow to create some of these annotation tools and things like that. And I think those are independently useful. If someone wants to use those things, that also makes sense. And finally, of course, we are hopeful that this benchmark will see some wide interest and people will try to use it. So I think the white paper about benchmarks is also given as a link here. So I think at this stage I'll probably come to an end of my talk, and maybe we'll try to answer a few questions at this stage. Thank you.
Okay, thank you, Professor Raghavan. We have enough time for questions. So if you have any question, you could write it down to the QA section in Zoom, or the panelists, if you have any question, you can just unmute yourself and ask questions as well.
So I have a question regarding so this is Anirban. Hi.
Hi, Anirban.
So I had a question. I want to, understand the first part of the talk, the one where you're talking about the clean room.
Yes.
So, technically, implementing the idea is nice, but implementing that technically, it does not look that obvious. That's I guess an obvious statement I'm saying, because what you are then seeing is that you have to the models that will be deployed have to either certify themselves to be differentially private. Basically, in some way, you have to certify that the models are not leaking any. You have to bound that information leakage. And how do you think we can do that? Is there a technical problem that we have to solve before this is deployed?
So, if you're talking specifically of differentially private, whether the models are differentially private or not, there has been a lot of recent work in the last 1 year, where there are some of these standard methods which in a black box manner, you can actually understand you can actually have some interesting bounds with respect to the differential privacy of the models themselves. I'd be glad to share some of those papers offline, but I think there has been some very interesting work in the last last year or so in this area as far as the differential privacy of the models themselves is concerned. Yeah.
Just to clarify, so we're not talking about developing differentially private algorithms. What we're saying is that anybody comes and I have to certify that this is a differentially private algorithm.
Correct. That's correct. So obviously if you look at pretty much most of the deep learning algorithms, now obviously there is some kind of accuracy penalty for being differentially private, but most algorithms have the differentially private versions of those algorithms are there, but we are not even saying that you need to train that way. You could train the model in any way, and then you can actually just pass it through the a differential privacy test to see that indeed that it is not violating differential, that it is meeting certain standards of differential privacy.
So we have a question from the audience. So the question is, normally centralized design approach is prone to single point of failure. Are these frameworks designed in distributed way?
No. Yeah. So there is nothing fundamental in this saying that this needs to be central at all. It can actually be. It can definitely be a distributed framework. That is not. Obviously, that is not something that the framework itself defines whether it is central or it is distributed. I'm assuming that you're talking about the first part of this talk. I don't think the second and third part that is that relevant. But in the first part of the talk, yes, these things. There is, in fact, there are many parts. There is obviously the concept of a logical clean room. A logical clean room actually even consists of many different entities, which may contain different parts of that clean room, and they may all be, and we've also worked out that scheme where actually it is the clean room itself is distributed across, and the clean room is running multiple entities actually run the clean room. The whole concept of this this confidential computing is coming up from the cloud vendors, and that's the interesting part, that that the cloud vendors are now saying that they want to be able to guarantee that not even their people, right, are basically able to access anything, that even though you're running on the cloud, that the privileged users within there. So that's actually the starting point, and they wanted to have this hardware root of trust to achieve this. Now, we were actually trying to extend this mechanism really, and by the way, a number of people, and I think that it is again something which is a new thing coming out. We believe that both all three, whether we are talking about AWS and Google and Microsoft, are all kind of going to come up with these kinds of confidential computing environments. But we are trying to extend that to to come with a mechanism that people can share data with each other safely in a confidential manner. That's the intent of what we want to do. This is obviously early work in the sense that there's a large amount of work to be done. But I think that thinking in this way and combining it with some of the legal empowerment that are there in India actually makes it very interesting and may allow people to share data in different ways.
So there is another question. So how can industry professionals like data scientists, ML scientists contribute to any of these different missions in their spare time or as volunteers? So I think that if you look at the first item, that is actually it's actually a completely volunteer group. So all of us are volunteers, and there are people and we are all volunteers under the ISPIRT umbrella. Okay, so therefore, and that is the ISPIRT as actually one of the volunteer organizations, which you may have not been aware that many of the kind of digital public goods in the country, like for example, they were responsible in defining the UPI interface. They were responsible for in the National Digital Health Mission. There are a number of different API, and of course, most of the people like me also have a Aadhaar kind of a background. But the intent is that is, so therefore, it's a purely volunteer organization. And so if you want to come and join these kinds of things, we do have these meetings and we keep discussing where some of these things go. And if you want to contribute in that area, that's certainly something that we can do. Of course, as far as the National Language Mission is concerned,
we are hoping that this whole data being open and being available to everybody is one way that we expect that and anybody also can contribute the data. Now, this is something which is the mission itself has not been launched yet, but we expect it to be fully open and available, this available for people to, because we believe that, as I mean, and I'd say this as an Indian, I feel that we should, we should own our languages, and we should, and that's really the intent of actually involving large numbers of people in whatever capacity they have in aiding their own languages. And the third one is also a volunteer effort. So please reach out to me. I'm glad to, I'll be glad to kind of connect and see whether there's an makes sense.
Okay, we have time for maybe one last question, if there is any. Okay, so it doesn't seem like it. So, so someone has asked you to share your email ID. So I guess.
Yeah. Yeah. So I think I'll share my email ID. How should I just put it over here, or what do I want to do? What's the right way?
So I think there's another question. Any application to blockchain?
Any application to blockchain? I mean, I think that I don't know directly. I mean, I think directly I don't. I mean, I think there is obviously kind of indirect ways in which these techniques used can also be used. When we talk about the very first one, things can be there can be things that can because to actually do those kinds of things, you need to have registries and some of those things. And when you have those registries, you can actually make those registries kind of public on a blockchain kind of an environment. But so therefore, there are certainly certain parts of those architectures where blockchains could be useful, but directly not related, I would say.
Yeah. So I have another small question, which is that we have a lot of uncertainty in our hardware systems.
Yes.
Like the cloud sometimes doesn't work. Most of the time, institute emails are unreliable. They begin to drop mails. So many of us shift to Gmail. So this sort of, these are small things, but this in one way builds up a little bit of it's loss of faith among people about getting the data, accessing the data. So this is
no, I think that your skepticism is well founded. I think the intent is that access to data, whenever we have said it, we have actually not even actually should be available for people has always been a challenge. And I think that in the end, we as ordinary citizens have to actually kind of try and see that how we can make sure that when we create some of these things, and a lot of the time I spend is actually to say that we advocate that this data be available and at all times. And I think it's something that, if we are going to look at some of these things, we have to make that as almost something that we consider as our first priority to making this data available.
Thank you.
Okay, so I guess that brings us to the end of the first talk. So let's thank speaker Dr. Raghavan once more.